Material instances allow us to create instanced copies of a single master material that can then be used in place of that master material. The benefit of a material instance is that we can expose certain material parameters of the master material to be modified without requiring a recompile of the shader while we work on it. This can create a significant time savings. Any additional work we do to the master material will propagate down to all material instances based upon the material changes. Keep in mind that we'll need to create a master material for each shading model and any other differences between the material's result node that we create. We're going to use this pre-built level here that I've created, and it has 4 shader balls inside of it ready for us to work. To find this map, we're going to go into our content browser under Maps, and you'll find it here called Material Instances. Be sure to load this up. Now, I've already gone ahead and created a material that we'll be using as our master material. You'll find it under Content Materials, and then the material is called M_master material. We'll open that up in the material editor. Now, this is a simple material. It's using the base color as well as metallic, roughness, and normal maps. And this is a pretty straightforward material right now. What we're doing is we're tiling the diffuse texture, and then we're multiplying the result by the color red and piping that into our base color. We're also controlling the metallic value with a simple scalar value here. And then our roughness is being controlled again by a texture, which is then multiplied by a scalar value to control the roughness. Finally, our normal map again is a simple texture. Now, something like this might work for most of your physically based materials in an architectural scene. And rather than recreate this material for every object in the scene, we can instead use material instances of this material. The first step is to convert some of these nodes into parameters. So we'll start from the very top here. The first thing we have is a color node here. It's a vector 3. We'll right-click this and choose Convert to Parameter. And then we'll name this Color. This is our first parameter, and this will show up in any material instances now created off of this master material. But we're not finished yet. We'll go ahead and create another parameter here by right-clicking on our texture sample, converting it to a parameter as well. And we'll call this Diffuse. We can see here that we're multiplying the UV tiling of this texture using a text chord node here, a multiply, and then a to vector here, controlling the U and the V values. We're going to convert this into a parameter as well, and we'll call it UV tiling. You can see that when we've done that, we have created an error in our multiply here. If we look down under stats, we can see the error is that float 2 and float 3 are not compatible. This multiply is expecting a float 2 because our text coordinate is returning a float 2, but our UV tiling parameter has been converted into an RGB alpha or 4 vector, and we just need the red and green outputs. So for that, what we're going to do is pull off of the red here, and we'll do a search for append vector. And then we'll add the green channel to the B input of our append, and then pipe the append into the B value of our multiply. And that should solve our error. Let's continue down the line now. For our metallic input, we'll simply right-click on the scalar and convert it to a parameter and call it metallic. Next, we have a texture sample for roughness. Convert that to a parameter as well and call it rough texture. We also want the scalar value that allows us to control the multiplier of our roughness, so we'll convert that to a parameter as well and call it roughness. Finally, we'll convert our normal map texture sample here to a parameter as well and call it normal map. Let's go ahead and see the result before we continue altering this material further. So we'll save it and create our first material instance. To do that, we'll right-click on the material and choose Create Material Instance. We're going to name this MI for Material Instance _ Master Material. Let's go ahead and open it up and see what it looks like. So here is a preview window of our material, and to the right here under Details, we can see all of the parameters that we've exposed. Let's go ahead and enable everything. So we have our diffuse texture, our normal map texture, and our roughness texture. Below this, we have scalar parameter values, and we have metallic and roughness, and then we have vector parameter values. We have color and UV tiling. If we open up color, we can see we have access to all of the values, all of the channels that we have, R, G, B, and alpha. Likewise, opening up UV tiling, gives us access to RGB and alpha. Just remember that the only values we care about are the red and green channels. So, for instance, if we want to now change this diffuse value, we'll go ahead and use the drop down here, and we'll pick a texture that we can use here. So I'm going to use this floor texture. For normal map, I'm going to change the flat normal drop down again to the floor texture. And for roughness, we'll change that to the roughness texture for our floor. It's called floor glossiness. For the metallic and roughness scalar parameters, if I click and drag inside the box, I can control those values. You'll also notice that as I go above 1, it allows me to continue driving that up, and likewise I can go below 0. The same thing applies to roughness. We'll look at how you control the minimum and maximum values here in a moment. And this brings us to our vector parameters. For color, I can obviously open up the color box here and tweak those changes by playing with the color wheel, or I could specify the values here in the RGB alpha channels. Now for UV tiling, the best way to control that is simply to enter the values here. So if I want to tile it by 3 on the U and then by 4 on the V, we can see the change there. Let's go ahead and save this now and apply it to one of the shader balls. We'll select that shader ball and then drag our MI master material onto the element 0 node here. Now let's make a new copy of our material instance here. Again, we'll right click on the master material, create a material instance, and we'll call this MI master material 2. Let's go ahead and apply this to the second shader ball. Here we can see the material instance in its default state without any parameter changes. Let's go ahead and create a third material, right-clicking and creating a material instance, and call this one master material 3. We'll go ahead and drag that onto the third shader ball, and then this time we're going to open it up and make some tweaks. For this one, we're going to change the metallic to a value of 1, and we're going to change the color to something more like blue. Then we'll save that, and now we can see the result of our changes. If we want to make any further changes, go back into Master Material 3, and for instance, we'll give it a different diffuse texture now. I'm going to look for rug, and we're going to use the rug diffuse texture here. And we'll also change the roughness down to a value of 0. You'll also notice that as we make changes to the parameters, they happen instantaneously without any need for a compile. One more useful expression in a material is a switch expression, and this node will allow us to control in our material instance whether or not we want to enable or disable certain functionality of our material. So if we right-click and do a search for switch, we'll want to use the static switch parameter. From here we have a true or false input and then our output. Let's go ahead and name this color switch. And we're going to use this to specify whether or not the diffuse texture should be multiplied by the color. So if it should, that'll be true. And we'll go ahead and pipe the multiply here into the true input. But if it's false, if we don't want to multiply, we'll go ahead and just use the diffuse texture output and pipe that into the false input of our color switch. From here, we'll take the output of our color switch and we'll pipe that into the base color of our master material. And then let's go ahead and save that. Let's check out the material instance now, and we'll load up MI master material. At the bottom here, we have our color switch. Let's go ahead and enable that. And with it enabled, this now allows us to use the parameter value, which is defaulted to false. Let's go ahead and enable it now. And we can see we have a green tint to our material now. Disabling it, of course, will return it to normal. Material instances will quickly become a core part of your workflow. They make editing materials far less painful, as we don't need to wait for a shader to compile every time we make a small tweak, as long as we're tweaking exposed parameters. Next, we'll look at how to better organize those parameters that we've added to our material instances.